Hi, everyone. I'm Heather. I know some of you already. I work with go-to-market at Altura. And more importantly, though, I'm here today with Lukas and Vasileios, and they're AI innovation engineers, also here at Altura. Vasileios holds a master's in data science and theoretical computer science, and he specialized in natural language processing and large language models and retrieval engines. So we're going to get a lot of information from him. And also we have Lukas, and Lukas holds a bachelor's and a master's in AI and has over 8 years of study and work in the field. So we're really excited. They've been with Altura for about 2 years now, and they're helping us shape our solution and are here to guide us through some of the new terminology we've been hearing. And they're going to give us a whistle-stop tour of how things work. So it's nice to hear about AI agents and AI and all of these things, but what does it mean? And I'm really excited because a lot of times I probably am talking about AI agents and nodding knowledgeably and don't know what I'm talking about. So, so I'm really excited to learn from them. So I'm just going to go ahead and pass it on over to you guys, and looking forward to talking to you guys in the comments.
Perfect. Yes, Heather, could you share? Perfect. Thank you very much.
Great.
Okay. Yes. So as Heather explained, this is our short little masterclass on AI agents, what they are, and especially how they'll work in your bid process. I'm going to talk you through what we're going to be discussing first. I think it's worth mentioning, of course, Heather already mentioned about the comments and the questions. If there's at any point that we're going too fast or there's a topic that we kind of go over too quickly and accidentally assume that it makes sense, please let us know, let Heather know, and Heather will flag us if it's important. So for at the beginning, as we're going through this, I'm going to be walking through these concepts with an example that you might all be familiar with, that you might all have done one way or another, where if you have a set of documents that you want to analyze and you maybe want to use further in your bid process, maybe a set of tender documents, and you want to maybe get the deadlines and the requirements, you maybe want to have these as a table and you want to do further tasks and further things with these, for example, kind of the start of your bid process. And this is going to be kind of a running example as we go through these concepts so that hopefully they make a little bit more sense. So while we're doing that, we're going to start off with this concept of LLMs, which you may have seen a lot, which is short for large language models. And we're going to give a brief overview of what they are and especially how they are used in AI and how they can be used in bid management. We're also going to then lead this into this concept of levels of autonomy and decision-making for computers and how that's relevant to getting from large language models to agents. And at this point, we'll have a little bit of we'll have a few different terms that we highlight. We'll be talking about enhanced large language models. We'll be talking a little bit about workflows and then finally agents. At this point, then we'll be hopefully done with this example of getting our deadlines and our requirements and automating further tasks based on this. And then we'll look at some other types of agentic workflows that you could use. We'll be looking at some more examples of agents and how they can be implemented in bid management. And finally, we'll be rounding off of a bit of a demo of something like an agentic workflow to round off. Okay, so let's get stuck in. I think it would be nice to hear from you guys here in what AI already is to you guys. What do you understand it to be? Do you use it daily? What would you use it for daily? I think maybe if you guys can share that in the comments, and then we can have a bit of a look at that as we get started.
Yeah, that'd be great. I've been thinking about this question too, as you guys are putting your answers in the comments. I was thinking about how I use it, and a lot of it times, Lukas, I don't know about, it's to make up for my shortcomings. Like I know some people know I only type with 2 fingers. I'm not very good at it, so I use it a lot for voice dictation or things like that. So I think and speak at the same time, as you may have noticed. So it's nice to be able to have that flow. Yeah, so a lot of mine is for AI note taking and things like that.
Yeah.
A lot of people use it daily. Great. I'm glad that, that you use it daily. How are you guys using it? I also use it for Excel formulas that I can never remember. I use it for like VLOOKUP that I'm always, or anything that starts with if. I can never remember those either. For basics, those said, yeah. Scanning documents, editing text, brainstorming, finding old text daily. Great.
Yeah. Classic.
Yeah.
Brainstorming is also my favorite use case. Yeah. It's another person to think with easily. Yeah.
Exactly. We have some of those there. Oh, and I use it to find where I need to go. I use it for Google Maps all the time.
Oh, very nice. Okay.
Yeah, because I have no sense of direction. I just have a lot of shortcomings that AI helps me with. Yeah.
Oh, perfect.
I use project features a lot, help with digging out specs when responding to tenders or producing first drafts. Great, Lanka. Thank you. And Paul, source information use and generating text. Okay, that's great. Thanks, you guys. Thanks for participating. Love it. Okay, I'm going to pop out again.
Yeah, that's great. All right, well then let's, with that information, look at this foundation of what are large language models and how are they used. Large language models are a very popular use of AI at the moment, and they are a very integral foundation part of what agents are. So we need to dive into this first in order to really get a grasp on how agents can be used and how agents work. So let's look at our example problem. Let's say you have a bunch of tender documents or some other documents that you want to analyze. You want to know what the deadlines are, if there's a planning table. You want to know maybe if there's any submission requirements, any evaluation requirements, anything else that's in there. And you want to not only know what this is, but you want to, use this information to drive further decisions down the line. For humans, this is quite a simple task. PDFs even are made for us, whether they're digital or printed documents, but even PDFs are made for us. They're not necessarily made for computers, despite the fact that they're on computers. We can just scroll through them. We see something that looks like a table, and perfect, we know what the information is. However, using a computer to do this for you is a little bit harder. Now it's a lot easier, but before the generative AI days, maybe you could write a little clever script that searches for keywords like planning or deadlines and hope that they're, always labeled that way in your document, but then it breaks if it doesn't have that information. It can get it could get very messy before we had AI to do this for us. But then a few years ago, we got this concept of a large language model. And I'm going to refer to this for now as a base LLM because they're going to get a lot better as I explain. And this base LLM, what they essentially did is they modeled language and they were made for text completion. So the name large language model is very self-explanatory. It models the data that it is trained on. And this training, you can imagine it as, for example, back in school days, back in high school, you might have these equations that you have to solve in a math class. Not very important, but maybe you have an X input and a Y output, and in the middle there's all of these letters and numbers, and you have to figure out what they are so that whatever you put in X, you get the right Y. These models that we make in AI, they're the same thing, except that instead of having just a couple of A's and B's in the middle, you have millions or even billions of these parameters inside. And what we want to happen is that they're all tuned correctly, the same way you solve these equations in school, so that when you put in some text, it would complete the text for you. That's what they originally made for, to complete text. So that if I started writing a story once upon a time, or maybe a long, long time ago, then it might finish it with in a galaxy far, far away and give me something like a Star Wars story. And these models then essentially were trained on all of the information you could find on the internet that was readily available. And over the course of months and with lots of money and lots of computing power, they were trained to model this data so that what's inside these models can recreate this data. Okay, all well and good, but that's not very useful for us. Maybe useful for story writers, but we don't want text completion. We want to be able to do more complicated stuff. So what happened next is companies like OpenAI and other researchers, they started getting these kind of core engines, you could look at these base large language models to be, and started training them to actually follow instructions specifically. So ChatGPT is a very good example of this. It really kickstarted a lot of the way that we use AI today. So rather than that these models would take in our text and finish it as if it's a story, they trained it that you could give it an instruction or a prompt, and then it would follow that instruction or give you an answer to a question, for example. So what we could do then, because of this, is we could get our documents, we could get all the text inside them, maybe split them into little smaller chunks, be as creative as you want, and we could get an instruction, also known as a prompt, like find all the deadlines and requirements in this project. And we can give both of those now to this instruction-tuned large language model, essentially just a base large language model that has been tuned or trained to follow instructions. And then we get an output. This might be something like you would see in ChatGPT, a response, sure, here's your table with all of your deadlines, here's your requirements that you wanted, and it'll give you this nice, speech bubble in text. That's what that's meant to identify, and you've got the information. Now, we could stop here, no? Well, the problem is that this is still just text. And computers need a lot more than text. Computers are not very, very intelligent. They need, if you give them a chunk of text that has the dates in it, they can't really do a lot with that if you want to do other things. They need to get inside there, and they need to be told specifically in a very structured way all of the information that's in there. So we can still use this for a lot of things. You can still, within your ChatGPT environment or anything else, you can ask more questions based on these deadlines. You could manually save this to a file and then send an email to somebody and do things with it yourself. But what you can't do yet with this, what we're at right now in this presentation, is do more automations. With the text that you get from ChatGPT or from one of these large language models is ask it to, maybe take the deadlines and the dates that are in this table and to, maybe make calendar items for them, or to assign tasks to them, or to all of the requirements that are in there. Maybe you want to automatically assign your colleagues and your teammates to those requirements so that they know they need to look at them. You have to do all of this manually right now, but ideally we could use a computer to do that for us if it's something that we have to do repetitively and over. Well, for that, we're going to need a few more things. Two things specifically. First of all, we're going to need to structure this information. So we need to get into this text that looks very nice for us humans and present it in a way that makes sense for a computer. The second thing that we need to do is we need to let the computer somehow make decisions about this. So it needs to be able to look at whatever the large language model found and say, all right, that was a date or that was a requirement. And based on that, decide what to do next. So that's what we're going to be looking at here. To solve these more complex problems, we need to empower large language models with this kind of decision-making process, this decision-making ability and the ability to structure information. Okay, we've been talking about decision-making. Let's look at an example of how this works. And to look at these levels of autonomy decision-making, we're going to walk through something that just happened. Valentine's Day was on Friday. Maybe they'll hate me for bringing it up again. Maybe it's a fun example. Either way, we're going to walk through this as an example of a way to explain these levels of decision-making and autonomy. You can imagine that all the way at the top of this mountain is a human that is fully intelligent, can make their own decisions based on information they get. And then at the bottom of this mountain, we have this base large language model. If we make it a little bit better, we get our instruction-tuned large language model that has this engine of a model but can follow tasks, for example, ChatGPT. Then we have this really long road up to a fully autonomous agent. There's lots to be explored on this road. There's lots of people working on it. We've been working on it for a while, but you can see there's a big gap between an instruction-tuned large language model and fully autonomous agents. And then finally, at the top, we have the human experts, obviously a level above what even the best AI can do. So for an example, if you can look at the bottom example as something that doesn't really require any decision-making, because we're talking about how you could, for example, set up your perfect Valentine's Day date, a lot of stuff needs to happen. At the lowest level, simple, repetitive tasks, or that you can easily do or instruct someone to do, like making a reservation at a restaurant. You don't need a huge amount of decision-making power here. We go up one tiny level, you still have these very simple tasks, but ideally they have a little bit more creativity, a little bit more ability to make a decision about how to compose a love note, how to write the perfect romantic thing, how to select the right flowers that are what your partner likes. And then when you combine all of these separate little small tasks and you're able to do them one at a time and reason between them so that when one is done, you know what to do next, then you have this fully autonomous agent that can plan and can execute these complex flows. So, for example, orchestrating the entire date. If you view a date, the entire plan is structured with all of these smaller tasks at the bottom. And then at the top, what AI can never replace is that final flourish, the kind of personal touch that makes a Valentine's Day date really special, the nuance and the depth that you need to make decisions on. So if you can keep this in your mind as we're talking about these levels of decision making and how, for example, there's a difference between what a human expert can do and what, for example, even an intern, for example, your company could do. We're looking at these things where you can delegate tasks and you can split them up into smaller steps, but all of them require some level of decision making. So with this in mind, how do we get from large language models to agents that can make these kinds of decisions? First, we need to tackle the problem of structuring this information. We need to power up our large language models so that when we use them, we can also perform other small steps, use other small tools, so that when I use my large language model, maybe I want to be able to retrieve special information from my database about something to do with my company. Maybe we want to validate the information. That could be a small tool. When we get output, we want to double check it against something. Is it correct? We want to make sure that it's at a simpler level, the right format, that it's a date rather than nonsense. We want to also have memory so that when we use our large language model and we maybe do multiple steps in a row, we want to remember what happened before. What were the previous inputs and outputs when we were using this large language model like ChatGPT? And when we have a large language model, which can generate text, gets an input, gives us an output, we add these little small tools that we can use with it, and we have this little bit of a memory where we're getting what we're calling an enhanced large language model. And this is relevant because this is basically this building block of agents which we can use to structure this information and make it more understandable for a computer. And specifically for this example, we could do many more powerful things with it. So with this example, we're trying to get our deadlines and requirements as a table for further tasks. Let's take this and we're going to feed our documents into it. And we're going to make one instance, one setup of this enhanced large language model. And the first time we use it, we're going to give it the task, find the dates in this document, just the dates, for example. And we're going to say once that happens, if it doesn't find any dates, there's no dates, then it's just done and it's finished. But if it does find some dates, well, maybe it just found them all in like one little jumble of a list of dates that's not really very legible for us. It doesn't really make sense, or you need to combine them so that you've got the right dates in the connected to each other, whether that's planning or submission or something else. So we recombine them. Again, we use the large language model with the memory and with the tools, and we give it the task based on these dates that you just got in the first step, recombine them. And then based on that, we can do it again. We can get another large language model or call the same one, doesn't matter. And we can get these recombined dates that we got, and we can tell them, okay, now put them in a structure that a computer can understand. And this gives us this output. So we've got this table, same one that we saw before. I put the little curly brackets around it, which is just a way for us as engineers to communicate to each other that this is structured information. This is something that a computer can store and can reason with and work with. And we're going to call this a workflow. This might be able to structure the information, but there's no decision-making happening yet. If you look at the arrows, this is, again, just a basic recipe that you could give to someone when they're cooking something. There's always, at every step, defined exactly what needs to happen. It can do really complex things, but only when we tell it exactly how to do all of those complex things. But it has solved our first problem. structuring the information. Now we need to figure out how we can let it make decisions so that we have to do even less of the hard work. And what we need here is one other thing. We have our large language model, which can take an input and it can generate an output based on that. It can take a question, generate an answer. It can take an instruction, and then it can follow the instruction. We've given it these tools, which can be any other small step, retrieving information from a database, validating the outputs, anything else you can imagine that you think this is a small step that a computer could do for us. We give it the memory so that it knows what were the previous steps in this workflow. And we give it the ability to plan and to reason and to control execution so that it can think and make decisions. So that what it can do here is it can take this instruction and it can see, I have these tools available. This is my task. What should I do? And then it makes a plan, and then it executes the plan. And while it's executing the plan, it can think, oh, it's not going as I thought it would, so I need to change some things. And this is an agent. The advantage of this is that we can let a large language model do these smaller, simpler tasks that we still need a human for. Think of it as when you get a result back from a large language model, you want to verify and double check that it's going correctly before you do go to the next step. Or maybe you get outputs from you've gotten outputs from your large language model and you want to put them into your Excel file. That's something you need to maybe manually do, but if it requires a little thinking process, a little bit of reasoning, but not full on expertise, we can use a large language model empowered with this ability to plan and to reason and to think about what's going on to do these kinds of tasks. So let's take a pause and we can kind of reflect on what are some real life examples of these agents that have, well, we could call an environment, being these tools, what's available and the instructions that it might get, and then it can think about it and make decisions. Some examples that you might have encountered in real life are some of these more intelligent versions of personal assistants, like Google Assistant, but also Siri and Alexa. They kind of have this feeling of I can ask it something, and then it seems to think about what to do, and then it performs the task. They don't always get it right. A lot of the time, I ask my phone to navigate me somewhere, and then it completely messes up the address. It decides that it's maybe in a different language that I'm speaking. So they're not perfect, but this is an example of where it does these tasks. Self-driving cars are a good example where they need to be able to see the road, see all of the other cars around it, whether or not someone is crossing the road or anything, and then make decisions based off of this information. Similarly, industrial robots, or maybe the more intelligent versions of Roombas, those little vacuum cleaning robots, they, understand what your room structure is, and they can, clean and move around autonomously. So these are examples in real life that you think of, oh, these are agents. And what's important with this word agent, the reason that we call it an agent is that it has an ability to act. So we could also maybe call it an actor, but that gets more confusing. We use the word actor more commonly in other elements of life. But it's, in that sense, it's an agent that it has this ability to think about what needs to happen and then act on it. So let's, with this example in mind of getting deadlines and requirements as a table for further tasks, see how we can use this. And we've got this example, this explanation, definition of what an agent is in the bottom left corner. It's a large language model with a memory, and with the ability to reason and to make and execute decisions. So what we're going to do is we're going to get our instruction. We're used to this. We're going to get our documents, and we're going to give it to what we call an orchestration agent. Maybe an unnecessarily complicated word. Essentially, the concept is this is something that needs to make decisions. You can also call it a manager agent if you want. They need to see the overall task and need to decide how to break that into smaller steps and execute it. And we're going to help it out. We're going to make this list of other agents that it can use so that it can build this kind of a team to execute tasks. So we're going to have this list of agents that are available, kind of a library of agents that are ready to be implemented however the orchestration agent wants. And what these agents have are their own tools that they can use. So for example, for the task of extracting and finding these deadlines and requirements, we could have one of them that is purely designed and perfected to only find deadlines in a document. Another one that is perfected to look for sub-award criteria in a document. Another one that is perfected to maybe create projects in an environment. Another one that's perfected to evaluate the progress and the quality of the output. Whatever you can imagine as a smaller version of this global task, this could be an agent. And what we give these agents is tools, such as the ability to interact with a database or to format text so that it's in a better format, or to generate a prompt for us, or to read a prompt, or to search the internet, for example, to do some more research. These are tools that we give to these agents, and we give these agents as sort of helper agents to this orchestration one. And we let this orchestration agent decide what to do. So it comes up with this plan for execution. Based on the instruction and what it has available, it selects the agents that it needs. It maybe finds the prompts that we have stored and that we know these work really well. Maybe it changes them a little bit just to match the task a little bit better. It decides what's the order of execution. It decides what the expected outputs are of all of this flow so that it knows, first of all, I'm going to call the deadlines extraction agent and I expect something that looks like a set of dates, and then I'm going to give that to the evaluation agent, and the evaluation agent is going to tell me yes or no, it's good, for example. And most importantly, it has the ability to change its approach as it's working. So it's not this flow that we saw before of step by step by step by step, where it has to do these steps that we define. It can define that itself. Now, this might suddenly be overwhelming and confusing, and you might be asking the question, wait a minute, how can an agent involve more than just one agent? And it's important to see this again from another perspective. If you think of your own team, you might have a manager in your team that makes decisions. That doesn't mean that everyone else below them can't make decisions. So everyone in their team can also make decisions. You can assign different people different parts of the task. They have different expertise and they have different tools available, and they know how to write a proposal according to, or the different parts of a proposal according to their skills. But it's the manager that's maybe making a plan and that's double checking that everything's going well. It's exactly the same here. So if we put all of this together finally to solve our problem, we have this agentic workflow. We have our instruction in our documents, and we give them to our orchestration agent. This orchestration agent has this library of available helper agents with their own tools so that it knows that it can call on these to do tasks for it. And it decides what it needs first is, it also has a memory so that it can remember what's been going on step by step. What it decides maybe first, maybe it decides something else, but for example, it could decide that the first three agents it's going to need are one to extract risks, for example, one to extract requirements, and one to extract deadlines. So each of these are going to look at the text, for example, it'll provide the text and they'll look for their own specialized information that they're good at looking for. And then it knows that after that, it's going to need a quality evaluation agent to look at the results of all of these little agents and double check that the quality is correct. Maybe the quality evaluation agent wants to do a little bit of online research and check, hey, actually, in order to check if this is correct, I'm going to need to do a little bit of analysis into whoever wrote the project documents, whoever is the tendering authority, for example, and see, I need to know more information to check if this is correct. Maybe it wants to actually just ask you a question. It's not entirely sure, and rather than making an incorrect guess, it decides, hey, I'm just going to ask the person who kicked off this process, what do you think? Based off that, let's say, for example, it says it's not good enough. So it gives feedback to the orchestration agent that has been setting up this entire flow. For example, what it could do now is it could say, in order to get this right, I need to double check all of the past projects that we already did. The ones that we already won, let's check the evaluations, let's check our past strategies, let's check if there's any way I can see better examples of good deadlines and good requirements. And then I'm going to use this and go through all of the flow again, and then get back to the quality evaluation agent, which maybe this time says, perfect, I've got this project overview that I can create now. I've got my deadlines that I can set up in my project. I've got the requirements. I can maybe assign them to team members, and we have an agent that can do that can create these key points and tasks for us to do. This is an example of how you could set up this kind of a flow, or let an orchestration agent, a manager agent, set up this flow where it can make its own decisions and reflect on the progress that's been happening so far. It can remember what's been happening because we've given it a memory. But at the core of this, if you zoom in on each of these, they're just large language models that have these tools, that have a memory, and that have the ability to reflect and look at and make decisions. And the reason that they're all dotted lines is this could change depending on how you set it up. Now, there's a lot of different ways of looking at these agentic workflows. It's not the most vital information, but just as an example of how you could look at this, that there are different ways. We could have a task input that gets handed to a manager agent that hands it over to his team. And as you can see, all of these helper agents are communicating with each other, and they get the process done. And then when it's done, it gives the task output. But we could also have that what the agent has is it's more of a centralized manager agent. So it calls them one by one, and then when one is done and correct, it decides to call the next one, so that there's less communication between these agents. This is just as an example that this is a very flexible, and it really depends on what the use case is, how you want to set it up. That these agentic workflows really are dynamic in that sense. So I think I'll hand it over to my colleague Vasileios now. And in the meantime, you guys can maybe reflect on what is a repetitive task in bids that you would love to automate as we get into more of the examples of how we can use these agents in the bid management tasks.
Thank you, Lucas. Yeah, so take some seconds, let's say 20, 30, to write in the chat what is a repetitive task you have in mind that you would like to automate with LLMs and agents.
Hi everyone. Thanks for sticking with us, and it's been really interesting. Thanks, Lucas, for sharing that. It was great. Yeah. So Martin says he analyzing Q&As on certain subjects.
Mm-hmm.
We have answering common criteria.
Yeah, that's a classic.
Yeah, quality checks.
Mm-hmm. For example, yeah, evaluation of
yeah,
better.
Great.
Mm-hmm. All right. Yeah. Thank you for your input. And then let's go to some examples, right, in the tender domain. So back to the analogy, like with Valentine's Day. Okay, we have all these tools to make a booking for a dinner and to plan a trip or get some flowers and stuff. But for different couples, for different people, there are different needs. And there is not like a perfect recipe covering everyone. Let's see how can these dynamic choices can be done with using agents. Now, let's go back to our tender-specific agentic ecosystem. So Lucas went really low level in how to create these structure output agents, so how to go from information chunks to tables to enumerated lists of evaluation criteria, of requirements of planning. Now, we already have the document analysis agent. This is called ABC, Altura Bid Companion, right? And this is responsible to get unstructured raw tender documents and extract the key information out of those. So requirements, evaluation criteria and stuff. Hint here, we'll have a demo by the end of the presentation, so stick with it. And then let's hypothesize that we have the evaluation tool agent. We already have as Altura evaluation tool, but an agent information of it being responsible to compare the incoming tender along with customer-specific context to see whether we have a good match, so we decide to bid for the given tender or not to bid. Now, we also need a customer knowledge base agent, for example, to obtain past proposals of tenders similar to the incoming one, or to retrieve the vision document of the customer, or other customer-specific information. It can be even like the ISOs we have as a company and stuff. And the last in the list we have the proposal writer agent, which is responsible for two tasks. First of all, write drafts and then self-reflect, so self-evaluate and reprompt itself to create better and better and better drafts. But, okay, we have all these tools, this nice ecosystem, but what is the missing part? To adjust the tools based on the needs, based on the use case. So what we need is a bit agent. This is an orchestration again, like Lukas referred, and this will decide the subset of tools that will be used and then the proper sequence. So it is responsible to adjust the whole flow to the specific customer, to the specific use case, if it is like an RFP or a public tender, if it is like in the construction domain or in the medical domain, to cover all these like dynamic needs. Now, let's have a look at three examples. The first example is a classic one, the bid no bid decision, right? So you get the unstructured tenders and then you want to decide based on your customer specific information, will I spend my time and effort and resources to create a bid about the tender? Okay, so by the way, the bid agents, of course, has a memory, and in this memory, it writes the interaction with the helper agents so as to be able to create this sequence of tasks and complete the whole objective. Now, as the first step for the bid no bid task, we'll call the document analysis agent. Why? Because we want to go from raw documents to the key insights, for example, evaluation criteria that are really valuable to decide whether we're eligible or not, whether we have a good match or not with a given tender. Okay, we'll get back an analysis of the tenders. So this will be written in the memory. So we'll have like the analyzed tenders, and then the bid agent will decide to go to the structure output agent. Why? Because we want to organize this textual information to tasks, to enumerated tasks. So let's say evaluation criteria number 1 can be sustainability, number 2 can be quality, number 3 can be price. So we need to give a structure to that, and this is the responsibility of this agent. So we get structure information, you can imagine in a table, and then what's the next step? To go to the customer knowledge base agent. Why? Because we have analyzed and structured all this rich information out of the tender, but we need to check whether this is a good match for our use case as a customer, right? So we need to check how well we performed in past similar tenders. For example, what were our evaluation on the specific criteria? What are the strong points? What are the weak points? For example, we didn't score that well in a similar tender in terms of sustainability. What can we do better? So we collect all this kind of information. And after we get this information back from the helper agent, we have the customer insights. Let's call it like this. And then the last step is to feed all these tender-specific information and customer-specific information to the evaluation tool agent to perform the matching, to give us a matching score between the tender and us as a company. And based on this score, of course, we can have a data-driven decision about whether to bid or no bid. So we'll have the bid decision. Now, moving to a second example. First of all, we all have tried to write more or less with GPT like a proposal, right? And a common discrepancy is that, okay, we have a first draft and then we prompt because we want to, for example, fix the language or the tone of voice or something, okay? But instead of fixing this problem, we fix it, but we created 2 more issues. So we don't include enough information and stuff, okay? So then we reprompt it to solve these 2 issues along with another one with some details we want to add, and we create 3 issues. And instead of converging to a better and better and better proposal, we're diverging to something that we cannot use. So we have spent a lot of time, a lot of effort prompting, a lot of our valuable patience, right? Only to not get something that is usable. Okay, let's discuss how this can be addressed with agents. So the task is writing a proposal, and the input is, okay, we give just like a basic list of evaluation criteria, and then optionally, if the user wants, some other information. Okay, so based on that, we need to write some drafts. Nice. So the bid agent goes to the proposal writer agent and requests for a proposal. Nice. Okay, first of all, based on the evaluation criteria and the context, the user input context, we want to collect the customer-specific context that fits to these criteria and this information, right? So, okay, search for past bids that address the same criteria and the same context as the user input. Okay, we collect all this information. So we have a context-informed proposal writer agent, which is nice. And then the writing task starts. Okay, so we start writing the first draft, and then we have it. And then the proposal writer agent self-reflects to see if this is good enough based on past proposals to give the first draft as the final draft, or reiterate and keep rewriting and keep reevaluating. Let's say this is not good enough. So we come up with a second version. Okay, and then we have the second draft, and then it self-reflects, etc., etc., etc. It can create 10 versions, but all the intermediate prompting is not done by the human, it's done by the agent. And this is really important because LLMs know how to reprompt themselves much better than human. Of course, the final decision about the draft is based on human, but the whole reiteration is done automatically, not by pressing buttons and spending so much time. Okay, let's say this is the final draft, and then it is given to the bid agent as the final output. So we have the final proposal. Now, I want to ask a question which will address, can AI win bids on its own? Right? So first of all, let's see how it could look like, and then let's discuss if it is possible or not. So the third example is the end-to-end tender management pipeline. What does it mean? So how to go from raw tender documents and some customer specific context to a fully written proposal. Again, the setup is the same. Let's say for simplicity, we do not include the evaluation tool agent because, okay, if it is automated, why to evaluate? Why not to bid like for every single tender to increase our winning ratio? So again, the first step will be to analyze the document. So we use the document analysis agent to get an analyzed version of the tender, and then we need, again, as a revision, to structure it into structured information. Now, based on that, we want to collect customer-specific context, past proposals, again, it can be vision, it can be the documents we have, everything, to have the customer's insights. Okay, we'll utilize all this context right now to write a full proposal, feeding the proposal writer agent, of course, as we discussed previously, with reiterations and some intermediate drafts. So then, with just like these tools, we can have a first version of a finished proposal. Now, back to the mountain, right? We start really down, and then we climbed up till the fully autonomous agent case. So we discussed how we can utilize helper agents and orchestrator agents in the tender management process to even go to the end-to-end tender management task, right? Now, the last 20% is not AI, this is you. Okay, AI by default can only imitate your way of writing, the generic way of writing, or utilize your customer-specific information, or analyze in a decent manner the tenders. But all this humanization step and all this tender intuition that you have built throughout the years, no, this cannot be easily incorporated. And this is like the crucial factor. This last 20%, it is what you need to touch the people behind evaluating the tenders, right? So if we go back to the Valentine's Day, okay, it's nice to have flowers and it's nice to have a nice dinner and stuff, all those planned, but who is the protagonist? Not the task themselves, the protagonist is the couple. So in the same manner, you add the final touches that win a bid. but you can save a lot of time to climb up to the 80%. Then it's all about you. Now, we'll have a look at the demo of the ABC, the document analysis agent we discussed in the platform. So let me share my screen. All right, here we are. So we have like a public tender, contaminated land technical review service, okay, with some documents. We have the appendices, we have like the main tender, and we want to analyze. Okay, we will call the agent, the ABC agent, Altura Bit Companion, to give us the analysis. So, yeah. So we have selected all the files, PDFs and docx, right? And we want to perform an analysis. Here you can see that we have like plenty of templates. Templates are preset information that we need to extract from the documents, and then we'll use like this one, the general analysis of the tender. So as you can see, the agent behind the scenes performed 3 steps. First, it processed the document. What does it mean to process the documents? The documents were read and analyzed, cut into smaller parts, and were ready for analysis. Then we had the analysis of the documents and of the report. And as a last step, we generate the report itself. Okay, for example, what we got from the documents. Who is the client? This was one topic. What is the publication date? Also like project details, key requirements, the dates of the planning. So the publication date and the submission dates and all the deadlines we have to respect. And then all the information, all the key information we demanded from the analysis from the agent to extract. So this is a really fast way to go from 9 documents from, let's say, more than 200 pages or something to just like a targeted summary with key information about the tender. So it's really easy to cut lots and lots of analyzing the documents one by one themselves. So as we can go to a bid, no bid decision, or even to write a proposal. So yeah, that's the tool. For more information, you can contact Heather or Talia, and then yeah, let's continue with the questions. Thank you.
Great. Thanks for that. Thanks, Vasileios. I appreciate it. And welcome back, Lukas. Just so you know, you're on mute before you try to answer anything. All right, we have quite a few questions, which is nice, exciting. So let's see, Natasha, you had quite a few. Let's pull up Natasha's first. Can you explain vector points in AI? Also, if AI can support with no-go decisions. I think that might have been a little bit of what you went over, Vasileios, but if you guys want to jump in here.
I'm not sure why what is referred as vector points, to be honest. But yeah, of course, it can support go or no go or bid or no bid decisions, sure. Because we have already like tools to analyze, and we have them already in Altura, and then, of course, there is AI can perform the matching, as I explained, between the tender information and the customer information to see how good a fit it is or not.
Great. Okay. If you just want to drop a little bit into with vector points, I think if I remember correctly, it's like something on a graph with like showing movement. But Natasha, if you could pop that in, that'd be great. And also one from Marnie. Can some of the tools being used by the AI robot process automation tools? So some set processes built for the AI to use.
Yeah. If I understand the question correctly, the concept is these tools that we can set up are as creative as you want to be with it. So the philosophy behind this is always make it as simple as possible. And if something doesn't need an agent or doesn't need to be able to make its own decisions, why overcomplicate it? We can just set up something that is a repetitive task that we know I always, with one part of my process, I always do step A, then B, then C, then D. There's nothing complicated there. then there's no reason to add decision making to it. So let's just automate that process. We'll make sure that that's set and structured and always the same steps. And then we can provide that as a tool for it to use, that we know that it'll always get the same output there. It's only when it comes to something that having that kind of a set process doesn't work and where we need to make decisions on it that we're like, okay, let's let it have a bit more freedom. But definitely when possible, if something gets the best results by being set and being more understandable and editable by you as a person, then yeah, we'll stick to that.
I think going on from that just a little bit, we have this one from Tice. Is it possible with the LLM workflow to automate to a standard setup for all tenders?
Yes, that's kind of something similar to what Vasileios was walking through there with it kind of end-to-end flow. The advantage of something with an agentic workflow specifically is that there's probably a little bit of difference between all of the tenders that you're working on. Even if they're within the same industry and you know that they're going to be 80% similar, the advantage of having something agentic, meaning you can make these decisions, means that where there is a little nuance of difference, it can slightly change in order to get the best possible output. I don't know if you have an elaboration on that, Vasileios.
Yeah, for example, for some tasks you need information out of the internet, or for some other task you need like another sequence. So first, like perform, go to the customer knowledge base and retrieve some information, and then evaluate. So it's different per case, per domain and stuff. So that's exactly the advantage of agents. We don't need to define something static because, of course, we can have something dynamic. But yeah, technically, of course, it's possible to create like a standard sequence of steps.
Then also, how do you stop the LLM agent from writing a response that is actually incorrect when it's trying to respond?
Yeah. So for this one, like after an agent and of course, in case of the proposal writer, at some point, if the agent is not so sure, it asks for human feedback. And then you have like a pop-out window that optionally, I need your help. Can you help me get the direction, right? So if the direction is clear, it keeps regenerating. But if not, human comes inside, and this is where the human factor comes with, or to give some ideas, some brainstorming, some direction to guide it where the tender experts wants it to.
And to add to this, I think it's important to remember what the base of all of these large language models is. And these are models that are trained on, first of all of the information on the internet, basically, and they're trained to be creative. That was the first thing they were told to do. So if it doesn't know the answer to the question that you're asking it, well, first of all of the information on the internet that we write is very confident. Very few people write an article online that's very tentative in what it's saying. People are very confident in what they put online and what they in the books they write, etc. And when it's trained to be creative at the very, very start, the first ones we had years ago, then that's what this large language model is going to default to. So if it's not sure, unfortunately, there's always a tendency for it to very confidently tell you something creative, which unfortunately could be very incorrect. So what we do for this, in order to make sure that we give it the best possible chance to be correct, is we always provide it with what, as far as we can find, is the correct information. So if, for example, if it's answering questions about a document, then we make sure that we provide all of the chunks of text from the document where the answer could be. If it's writing a proposal and it's basing that off your previous strategies or your previous proposals, we're making sure we're providing it with that. And then hopefully, as far as possible, it is using that to be correct. The advantage of an agent, as Vasileios just says, is that on top of that, we can let it reflect and we can let it look at what it was generating and give a better answer. And for example, getting multiple agents, using different models to support these agents, for example, and letting them vote, for example, on whether something's a good answer, and being creative there, that gives these agents a much better opportunity to be correct and to then so not to generate something that's factually incorrect. There's always the smallest possibility that it will still be incorrect. which is why it's always important to just double check that before you make a very important decision based on AI, is it actually based on reality?
Great. Also, we've had a few questions on things basically on the security of your information. So Kai was asking about when you're publishing this information, and he went on to talk about it. How is it that we can ensure, or you can ensure on ChatGPT or things, that your information isn't being shared with your competition, which is like a common concern I hear as well when I'm talking to people.
Yeah. So this is definitely a very important question. And the answer really depends for when you're using it yourself, in which models you're using and where you are specifically and how you've done it. If you yourself are going into ChatGPT and using it, then you need to make sure that you're setting these settings that say, hey, don't use my data to train your models anymore. But that's very much region dependent as well. What we do at Altura is we have specific ways of accessing models like OpenAI's models that are hosted via Azure and only in the EU. And these endpoints, they're following the EU data privacy laws, so that any information that is being sent there, they only keep for as long as possible to answer it, and then they throw it away. So by using these endpoints, there's no possible way for the models that everyone else is using to store your information and to use it to improve their models. That's not happening. It's only being kept as long as it needs to write the response. And then for us, with the data that, for example, if you're at Altura would give us, we keep those in private environments, and we make sure that they're only being used to prompt these models within your own environment and are completely separated from everything else. So then you have the advantage that we get to use these models and get the right information, but we're making sure that all the data is separated and nothing is being used or stored long-term by the models themselves.
Mm-hmm. And like for the short future, right? When we utilize customer private information to train models, there will be like one deployment per customer. So the models, they will be decoupled themselves. So you cannot have any leakage of data from one customer to the other, because every customer will have their own private model, the private deployment, I mean, right? So, yeah.
Great. We're at time. Can you guys stick around for just a couple of minutes? We have a couple more questions.
Mm-hmm.
Great. Chris asked, can the agent assist with the management of the wider subject matter experts and tender team to help with bid workflows? So now, from just a little bit of color, because I've talked to a lot of bid professionals. So one of the issues or the challenges they have is they have all these subject matter experts that are working on they have a different job, but they're also helping and advising on those proposals. And there's a lot of management around that, like when they're going to be free, if they're going to be able to have the time to weigh in and things like that. So I think that's what you're talking about, Chris. Am I right? We'll wait for him to get back to us on that.
But yeah, I think, I mean, it's all about like task management, right? So of course, this is not like part of the basic workflow we discussed, but we can, I mean, the AI behind the scenes, the agent can understand which domain-specific task go to which specific employee, right? Check availabilities, and then do the task allocation based on availabilities, based on dates and stuff. So, of course, this is possible, but I think this is like a much more like a specific application than the
Mm-hmm. Great. And then Bilal, sorry if I'm saying that incorrectly. He was saying, or she was saying, I'm sorry, are company documents like past RFP responses pre-indexed or need to be uploaded?
In the Altura environment specifically, as far as I understand this question, the documents that you provide to us are what we use. So if you want previous proposal documents or responses to be used in this, then you upload them to our environment as needed, and I think can I guess provide them at the beginning when
Yeah,
signing
it's
up,
part
and
of
then
our
we make sure they're
onboarding. We
available.
put everything up for you.
That's what I
Yeah.
was looking for. Yeah,
Yeah.
onboarding, and then we make sure that they're available. But then when you have new ones, you can always need to upload new ones there. Make sure that they're available.
Yeah, so you have like as a customer, you have your own document vault, which is like a repository for your vision documents, the past tenders, whatever you want to upload. And then you can create a project, in this case, for an RFP based on these documents, or upload other documents, or combine both, right? So yeah, it's fully feasible.
Yeah. Great. Well, thanks everyone. Thanks for sticking with us. We ran a little bit over. I think I caught your questions. If I missed any that you want some answers to, or if you think about it later on, or any of you that are watching this that weren't able to join, just reach out to me. And I'm happy to answer any questions you have, or put you in touch with the person who can if I can't. So I can always get those for you. But thank you so much for joining. And thank you, Lukas and Vasileios, for sharing your information and knowledge. It was really informative. I learned a lot. So thanks for that.
Thank you very much.
Thanks a lot, Heather.
Thanks. And everybody have a good day.